So it's time to revisit this Atari Lynx again. You might remember that the last time we looked at it, we diagnosed that this screen fault, where you can kind of see a few flickers here and then the rest of black screen, is actually potentially related to the Hayato chip. So the screen is definitely good. The console definitely boots. The RAM seems to work. So the next step of the diagnosis would be either to completely scope out every pin on the Hayato chip and go everywhere on the schematic in terms of figuring out where this goes. Or what seems like a quicker option in this case is to simply swap the Hayato chips over from this known working board. So the time involved in diagnosing every pin on this chip is going to be much longer than simply swapping the chip, until at least we gain more knowledge of the Hayato chip, where we could potentially prove much faster if the chip's working. So until we've built up a more advanced knowledge base of the inner workings of this chip and common symptoms or faults that may result in black screen, I'm going to make the presumption it's this chip for now. So we're just going to do a blank swap and see what happens. This is already known working. This is known working except the black lines. So let's just go ahead and basically hot air this off and swap it over and see if we can get it working. So I'll just take the game out. And when you're hot airing, you want to have a plan of attack. So we don't want to melt this, because obviously that's plastic. The crystal's got some wrapping on, so we might want to protect that, and there's plastic here. So what we can do is just grab some aluminium foil. We sell this on retro6.co.uk, along with pretty much every tool you'll see me use. And just remember to remove this once we're done, because this is conductive, this is actual aluminium, so this is going to short circuit things. So don't apply this while you have power applied to the board. This is purely just for while we're reworking. And the idea of this is it will block some of the heat from going onto components. So I'm just going to cover, for the sake of it, considering it's nice and easy, I'm just going to kind of form a square around the chip. And in corner like that, where we've got a crystal, you want to try and get it stuck down so hot air doesn't flow underneath. Otherwise you're not protecting that much. The hot air will just simply blow under and still do its damage. And even with the tape on, you don't want to just go blindly blowing hot air anywhere. You still want to consider what you're doing. So I think that's covering pretty much everywhere we're going to be touching. I'm going to expose them pins, and I'm just going to do the same on the working board. And again, before we change chips, I like to also write on where they're coming from. This is the Retro 6 chip, and this is the customer's chip. Also bear in mind the orientation, so Atari's upside down. So I can write a letter A sort of here to indicate, the Atari facing that way. So we'll start by removing the potentially faulty chip. And I'm just using the quick hot air station. Again, as mentioned, we sell these if you want one. Hot air is set to 480 degrees and 80% speed. So I'll probably go up to maybe 490 and 90, I think it's probably, or 490, 85. And again, until you've worked on a specific console for a while, you'll find the best settings for each item that you're working on. But this one is fairly simple. I'll just go around the outer pins, go above a little bit in general for 10-20 seconds just to warm this board up. Trying to direct my heat downwards from the board so it doesn't blow sideways and knock chips off. And then once I feel the board is warm, so we're not going to get too much thermal shock, you can go back in close to the pins. If it's anything like Game Gear, this will probably take about 1 minute. So I'm not even going to bother trying lift for now, I'm just looking for the solder to be melting. And I can see the solder is already starting to melt. So I can go underneath the corner of the chip, and I'm not applying any kind of force. I'm just naturally letting the tweezers rest under. And you'll find that once everything's warmed up, you'll see there it's nudged off already, nice and easy. So don't rush it as soon as you see it moving. Just take your time. And there we go. So that's the chip off. And we can see them are pretty clean and look like they're going to be pretty easy to put back on. So we'll just move that out of the way for now. Swap boards. Do the same again for the working chip. And we can pretty much rely on the time again to be roughly the same. So I just did a little bit, and again, distance wise, I'm sort of that far away for those that are interested when I'm warming the board. And then when I get closer, I go very close. So distance wise, I'm probably 2 inches off the board for a general pre-warm, and I will go to like 1 centimetre away when I'm warming up the pins. Tend to focus your preheat on the chip as a whole on the board, kind of this area, and your directed heat just straight on the pins like this, going around the pins. And again, just keep everything pointed directly downwards, and it will prevent any potential knockoff of components and make it much less likely. If you guys do attempt this and accidentally knock any chips off, obviously just let me know on the Discord and I can measure the components and let you know how to find replacements. They're all basic resistors, caps and inductors that are replaceable, so don't worry too much if you knock things off doing this. And there's the working chip off. And you can see, just as I said that, I was looking at the camera and not there. I've knocked this resistor, so just plonk this resistor back on. And then on this board, let's just do this one first because we have a few bridges and we also want to replace this solder with leaded solder for easier rework. So I'm just going to go over all them pins again. And that's that board done. Now let's grab the customers, do the same thing. Put flux on the pins. And now we have all this board prepped. Even though we've put flux on, it's important to clean all the old flux off and all the old residue so it's fresh. And once we've done that, reapply some new flux. And all that's left to do is place the new, well, the known working Retro 6 chip down. But let's just inspect this for shorts as well. So we want to make sure none of these pins have shorts on. And quite a few do. So let's just resurface that as well in the same fashion. We'll just put flux on all the pins. And just do a quick visual check that none of these pins have any shorts before we start. We can lightly remove them when it's on the board anyway, but the less work we have to do afterwards, the better. So that looks all good to me. And before we solder this down, I'm just going to hold it in position and try and tack a few legs on. So it's tacked in a few corners now. And it seems lined up enough that we should be able to hot air this down. Apply a little downward force on here to keep it in place. And just go around nice and close to the pins. That flows in nice and quick with it being leaded solder. And now we can take a look at all the pins. And it looks like it's caught all the pins. And if we're in any doubt about the pins, we can just obviously reflow with our iron. We've obviously got to let this cool because that'll be quite hot. And let's just remove this tape as well while we're waiting. And it looks like we haven't caused any damage with the hot air. And that's coming down to touchable temperature. One last inspection just to make sure we haven't knocked any components off in the vicinity of where we've just worked, which I don't think we have. So we're looking all good there. So I think we're good to test again. So fingers crossed this works. And fingers crossed we obviously have all the solder points. Let's put the audio back in. Screen back in. Power. Log in, and let's short TP 17 and 18 again. And what do we get this time? Well, we've got exactly the same issue on screen. So it's not the Hayato chip, which means something else on this board must be controlling something about displaying output. So those 4 output pins are controlled somewhere else. So just to prove that, let's just swap the other Hayato chip back onto the Retro 6 board. And let's make sure that the customer's Hayato chip is working. So this will prove then that we have 2 working chips and we can take the next steps. And this is the benefit of having a fully functional console, is you can hot swap parts between them like this and prove, you know, what things work and what things don't. So this will happily prove now that the Hayato chip is fully working. So we just got to let that cool down a bit, still quite toasty, before we power it up. Let's just get the screen in ready. That's cooled enough to touch now, so moment of truth. Based on the fact that the customer's board is acting identically as it was before. So if all logic stays true, this should work, presuming I've soldered it right. Yep, and there you go. There's the game loading as before. So that's good, we've learned something new. We know that the customer's CPU in essence is good, the Hayato. But we're now at a mystery point where the presumption we made so far means there's something else involved that isn't just this Hayato chip and RAM that controls the, specifically, only the 4 pins of data out of this chip. So every other pin, if you remember, on this LCD connector is valid. It's outputting valid screen data, but it was outputting actual black data. So what we need to do now is go to schematics and take a look at our next step. So let's revisit the schematic and let's take a look. We know the power circuit's good, as we mentioned, definitely, because we have all power. We have all the contrast, we've seen it with our own eyes. The backlight works, so it can't be any of this. This contrast circuit, the entirety of the circuit must work because we probed the final 4 pins out. So we know the bottom half of the schematic, without any shadow of a doubt, is fully working. We are making a presumption that this ROM cart works because we actually get ROM data. And these switches are for shifting the ROM data between the cartridge and the system. We know now for absolute certainty that the Hayato chip is fully functional. We know the audio works. These pins are suspicious in a sense, but not necessarily fully. They clearly say like audio in, color black and white. Maybe this color black and white pin is something to look at. Maybe if it's black and white, it screws up the LCD data and this was never meant to be, you know, exposed to the LCD. So that's possibly a simple thing to look at. Just probe pin 14 on the oscilloscope. The power on button's nothing to do with it. The crystal isn't. Motor on, I doubt again. The RAM we can't be absolutely certain of because, as I mentioned, if the video data is stored in, say, a certain part of the RAM all the time, say the higher order parts of RAM, it might read the game data at the lower half and then read the video data at the upper half. If the Hayato chip isn't storing the video data, it still might be, and just not outputting it, due to some other pin. But my presumption is to store a full screen of data in pixels would probably require RAM. So we could well be on the possibility that the RAM, the upper half of the RAM, is no good, or the address or data pins at the upper half don't get to the chip. So it's probably worth just probing the Hayato on the actual data and address pins. So I'd say my next suspicion, the obvious one, would be swapping RAM and obviously probing the data and address pins directly on the Hayato. We eliminated RAM mainly through a quick test of shorting out data pins, but giving it some thought, video data might be stored in upper RAM. They're normally in a fixed location, so it might be reading the game data in and out of this, and then storing the video data in a specific address that maybe requires address pin 7, for example, that might be bad. We can't really check the buttons work on the SUSI because we can't see the screen. The backlight off circuit is of no concern either, so there's very little left bar really the RAM and probing the Hayato. So let's just quickly probe pin 30 to pin 47 on the oscilloscope. So let's just set up the scope correctly. We'll set it up to 10 volt. We'll do about 50 microseconds, and we'll set a trigger of roughly 2 volts. Let's turn that volume down a minute. And let's just start probing around the Hayato chip. So we know here is the start of the address. So here's address 7. And you can see there's address. That isn't connected. The next one is pin 32, 33, 34, 35, 36, 37, 38 all fine. 39 isn't connected. 40 is the data pins. I'm not 100% sure that looks right. So we have combined signals sometimes. See these higher peaks here versus the lower. Not 100%. We could compare that with the working one. Slightly suspicious. That data to me doesn't look right. It's classic signs. Yeah, something's wrong with the data pins. So let's just keep going a minute and we'll go back and double check that after. And all I'm really looking for here is, as I've mentioned, some kind of drop in the amplitude, so the voltage, instead of being 5 volts, it being something less, or something that looks like a fine trace, but with no signal on it. And you don't need much knowledge at the start about this. You can just probe around and literally look for potential missing signals without knowing anything else. There's the data of the screen that you can still see is just outputting black. So we know those are just outputting black. And everything else so far looks fine, but the data to me still stands out as not quite looking right. And I know data can look like that. It's not to say it's definitely wrong, but I do suspect it doesn't quite look right. This pin has nothing but goes to a cap. Just try to remember that one because it's got a trace coming off but doesn't appear to have any voltage on. And then we've done all these up here. So my only suspicion is these data pins. So bear that in mind how that data pin looks. And now let's just swap to the working board, and let's see what that data pin looks like on a working board. So without waiting for the game to load, pretty sure it's going to load, let's just probe, say, the data pin up here. Yeah, and look at that, completely different. So there's no fighting for data. It's pretty much all 5 volts for the most part, and either way this is the identical game and should be showing identical results. And that is quite clearly different. Same again there, everything's pretty much sitting above 4 volts. My next presumption would definitely be then something to do with data. The data pins, that's the only thing I can see on that entire Hayato chip that to me doesn't look completely normal. So we're looking at these 7 lines here, data pins. That's what doesn't look right to me. Now the data pins are driven, so actively driven high or low, by the 2 RAMs here, by the SUSI chip, and by the Hayato chip. Now which one drives the line is controlled by this row, RAS, call CAS, write enable, buzz request, and buzz grant. So the question is now, and bear in mind when you're normally doing repairs, we could do swapping the SUSI, swapping the RAM, swapping the other RAM, measuring everything. We will find the solution. It's not a case of, can we solve the problem? What you're trying to do when you're repairing these things is make the most time-saving step towards fixing a console while at the same time growing your knowledge base. So When you have no knowledge, like at the moment we don't have much knowledge of it, the next logical step, which is based on some good assumptions, is the Hayato chip is bad. We've swapped that and it isn't, so now we know the Hayato can output black screen but still load a game, and it's not the Hayato chip itself. So that knowledge is important, and we'll write it down and add it to the wiki. And the next question is, we can see something we don't like on the data pins, and it makes sense that video data is normally stored in RAM. So could it be RAM? Could it be SUSE? Or could it be something else? My guess is on one of these three chips now. So what would you do next? Would you use the oscilloscope to probe the RAS, the CAS, the write enable, and all of these pins? Would you remove the SUSE on the working console to see if it still boots? And if so, it's probably good to just whip off the SUSE off the other one to stop it interfering with the data pins. Or would you remove the RAM, in which case we would have to find another board, which I probably have, with the same RAM packages, and hot swap RAM. Bear in mind the hot swapping of RAM takes me about 5 minutes. Probing for information takes roughly the same time. So which would you choose? Would we now go down hot swapping one to all three of these to see if these are related? Or would we go down the oscilloscope and diagnostics route? But bearing in mind we've already probed these pins and they don't look right on the oscilloscope, so bar the fact of these control pins possibly not making it to one of these three chips so it stays in control, I think that would probably take a bit longer than hot swapping at this stage. So let me know what you think, and then we'll continue this repair. I hope this is useful for you, seeing the actual diagnostic steps and how you learn and gain information instead of just blindly swapping chips. This is about building our knowledge of the console, making assumptions and proving them right or wrong. So we will get this console up and running, no problems, but let me know your next steps, how you'd like to see this proceed. That's it for this one, and I'll catch you in the next.